everyone, my name is Olivia.
And I'm Kirsten.
And today we're enjoying a campfire on this cold summer night.
Enjoying some marshmallows and sipping some soup.
Sun was pretty hot today though, wasn't it, Kirsten?
It was. Did you know that the sun is actually a star?
No way.
It's actually the closest star to Earth. Only 93 million miles away, that is.
I didn't know that, but I did know that the sun provides light, heat, and energy.
That's right. The sun provides all those essential things. It's actually vital for our survival.
I get it now. Energy comes from the sun in form of light in the form of light energy.
Yeah, and actually, it's that energy that has the ability to cause motion and produce change through light energy.
Light energy can be converted into different kinds of energy, such as thermal and solar energy.
Exactly. But Olivia, do you know what thermal energy is?
Thermal energy is heat and comes from the motion of tiny particles in matter. The faster the particles move, the warmer the matter can get.
And solar energy is the energy that sunlight provides to give us electricity in our homes.
Just like how some houses have solar panels on them to save electricity.
Yeah, that's what I'm talking about. Some houses have those neat solar panels. It's a cool idea.
I agree.
A great example of thermal energy could actually be right now.
Because we're wearing coats to keep us warm.
And our coats serve as great insulators.
An insulator is matter that slows down the transfer of energy to keep the cold particles away.
And it slows down the transfer of energy because thermal energy is the energy associated with the random motion of particles in matter.
So thermal energy in essence is kinetic energy.
Basically. And we need a coat because thermal energy from ourselves is being transferred to the cold air around us, making us cold.
I thought of another example of thermal energy.
What is it?
Us roasting marshmallows right now.
Huh.
Because when thermal energy is transferred from a fire to the marshmallow, it's providing heat and softening the marshmallows.
So the particles in the marshmallow are moving around really fast, creating thermal energy.
Exactly.
So I have a question, Olivia.
What is your question, Kirsten?
If our coats serve as great insulators, what are the opposite of insulators?
Oh, that's simple. A conductor is matter that promotes the transfer of thermal energy. Metals are usually great conductors.
Oh, cool. So my spoon is the perfect example of a conductor. Did you know that thermal energy can be transferred in 3 different ways?
I know one way, conduction. That's when thermal energy is transferred through solids.
Interesting. And another way is called convection. And actually my soup is the perfect example of that. Because the soup that I'm eating, the thermal energy is being transferred through the use of the liquids and gases.
What's the last way thermal energy can be transferred?
Radiation, which actually brings us back to the beginning of our conversation, because that's how the sun warms up the earth.
Wow, we learned a lot today, Kirsten.
We sure did, Olivia. And it all starts with the sun.
The sun provides light energy and converts it into heat as thermal and solar energy.
And thermal energy is just the random movement of particles in matter.
And thermal energy can be transferred in 3 ways: conduction, convection, and radiation.
And don't forget about conductors and insulators. Conductors are simply materials in which energy is easily transferred. And insulators, they're just the opposite. They're materials in which energy is not so easily transferred.
That's why we're wearing coats to keep us warm.
Yep, our coats keep us warm.
And eating marshmallows is always fun too.
As well as sipping on some nice warm soup.
Well, that's our lesson today, everybody. See you next time.
See you later.